Hello there. My name is Sharon Hoyer. I'm the Clinical Nurse Specialist for Emergency Services for Hoag Hospital. I'm going to talk about predicting massive transfusion protocol using a smartphone application. Every year in the United States, 30 million blood components are transfused, and every 2 seconds, someone has a need for blood. Over 41,000 blood donations are needed every day, and one car accident victim can require 100 pints or more of blood. Trauma is the leading killer of Americans from age 1 to 44 years, and there are 18 deaths per hour from traumatic injury. Trauma is generally divided into penetrating or blunt trauma. Penetrating trauma refers to gunshot wounds, stab wounds, and injury from projectiles. Blunt trauma can include assaults, motor vehicle accidents, falls, explosions, and other force mechanisms. Having the ability to predict the need for massive transfusion protocol using a mobile application illustrates the convergence of technology, devices, applications, and improved patient care at the bedside. The use of massive transfusion protocols is not only used in the military setting, but is now common in civilian trauma centers and community non-trauma hospitals. The need for massive transfusion protocol occurs commonly in the trauma patient population, but also occurs in the emergency and inpatient populations as well. Besides traumatic injuries, patients with gastrointestinal issues such as esophageal varices, upper or lower GI bleeding, and the postpartum setting often see the need for massive transfusion protocol. Having the ability to predict the possibility that a patient may require massive transfusion protocol through the use of a mobile application would enable forethought and preparation when planning the patient's care. It would also provide time to prepare the necessary blood products in anticipation of massive transfusion and allow for typing and screening of the patient. Type-specific blood products could then be made available to the patient instead of the uncross-matched blood products that are usually given once a massive transfusion protocol is identified. By receiving type-specific blood products, the chances of a transfusion reaction would be reduced, as would cryoprecipitate wastage that often occurs during massive transfusion protocol. Although there have been several prediction tools developed for anticipating the need for massive transfusion protocol, they are often difficult to use or have sacrificed predictive power at the cost of user friendliness. Many prediction algorithms require memorization of scoring systems, increasing the possibility of operator error, and additionally require discrete variables. For example, heart rate greater than 120 or systolic blood pressure less than 90, to make it easier to tally these results. Although improving the simplicity of the algorithm, this method can often reduce its predictive power. The trauma-associated severe hemorrhage, TASH, and assessment of blood consumption, ABC, scoring systems are two non-mobile application scoring systems that are commonly used today. The director of the blood bank was selected because not only was he instrumental in the research, development, and finally implementation of the massive transfusion protocol for the organization, but he also oversees the massive transfusion protocol process, data collection, and blood product sourcing. Along with performance improvement, he presented the background and rationale for the implementation of the massive transfusion process in over 100 didactic sessions for medical and nursing staff members. He is also a source of information regarding regulatory requirements as they relate to blood donation, transfusion, and blood product acquisition. The Information Technology Clinical Experience Lead was chosen for his background in information technology and work with multiple mobile applications. He has worked with various mobile technologies in the organization, from apps to simultaneously videotape a speaker while sharing the screen with the speaker's PowerPoint presentation, to work with programming the robot in the emergency department and critical care unit. The performance improvement representative was selected as she worked with the blood bank director in presenting massive transfusion protocol data in the didactic classes, and she regularly presents data at the Department of Critical Care Nursing, and Rapid Response Team meetings. She attends the mock drills that have been done previously and looks forward to the regular drills for the DMP project. The DMP project is one of performance improvement, so as a stakeholder, she is a key member in assisting with project implementation. All collaborators felt that this was a valuable application and would like to see it adapted to the non-trauma setting. The IT lead saw the value of the application, and in addition to the base deficit, heart rate, and systolic blood pressure parameters, felt that instead of the mechanism of injury parameter used in the current trauma application, perhaps further study could be done using 3 parameters of GI bleeding. For example, esophageal varices and upper and lower GI bleeding, making this application suitable for this non-trauma patient population. The blood bank director liked the application and its potential to prevent the waste of blood products, and Quality Improvement saw the application as a means of providing more expedient and better patient care. The mobile application selected is a smartphone application that uses the entered mechanism of injury, heart rate, systolic blood pressure, and base deficit to calculate and predict the patient's need for massive transfusion protocol. This mobile application was developed after looking at 394 trauma cases that ended up requiring massive transfusion protocol and was accurate for 97% of all the cases. With this level of accuracy, the patient's need for massive transfusion protocol can be predicted with high certainty, and steps can be taken to adequately prepare before the patient reaches a crisis point. The application also differentiated the full massive transfusion protocols from the massive transfusion protocol activations that did not meet criteria or require massive transfusion. It was determined that out of 44 input items, only the mechanism of injury, heart rate, systolic blood pressure, and base deficit were true predictors of the need for massive transfusion protocol. The application has 3 tabs for mechanism of injury, gunshot wound, blunt trauma, and stab wound, and slide bars to enter the patient's base deficit, heart rate, and systolic blood pressure. At the bottom of the application screen is a Predict tab to push once the required information is entered, along with a Records tab that stores previous readings. Results are provided in both percentage and a categorical scale of high, moderate, low, and very low. Because this prediction model is embedded in a mobile application, the data collected can be streamed into the cloud. This provides a potential for the model to be rerun with each new case, and it could be set to slightly modify itself through repeated learning to yield an ever-improving predictive capability. The application model was validated using the Least Absolute Shrinkage and Selection Operator, or LASSO method, which estimates model coefficients while providing less complex and more predictive models. 10-fold cross-validation was used to keep the model deviance within 1 standard deviation of its minimum, optimizing the predictions. This process was repeated 500 times and calculated for each one, using trained data as well as new unseen data to validate the model and provide sensitivity and specificity of the model to predict massive transfusion protocol. The mean of these 500 samples was also calculated in the area under the receiver operating curve, with a result of 0.96 for sensitivity and specificity. Attempting to calculate these predictions by hand would be very complex and time-consuming, with an increased potential for error. And since most medical professionals routinely carry smartphones with them, mobile application accessibility is commonplace. Using the mobile application provides efficiency and accuracy while minimizing the potential for operator error. Although this application was developed for use in the trauma patient population, further research is needed to see if the application could be adapted to the non-trauma patient population. Use of this application is innovative as it was created from the intersection between medicine and mobile technology and demonstrates device convergence where the smartphone is used as a diagnostic and predictive tool. It is an example of working more efficiently with readily available technology and provides better care for the patient by calculating clinical signs early to predict the need for massive transfusion. Thank you.